Hello students, this is lesson U1A01. In this lesson I am going to go over exercise U1A01b, which is solving a system of 3 linear equations. Now in the previous video we went over this question over here already. I am going to go over another question, which is this guy right here. I encourage you to pause the video and try this out on your own, see if you can use the same technique that was displayed in the previous video for this problem here. So hopefully you guys had some time to think about this. I'm going to approach this problem just a little differently, just for demonstration purposes. There's really no requirement, whether or not we have to start in the middle here to eliminate, the y's, as this question here is suggesting that, it's set up so that eliminating y would be the easiest. I'm going to approach it just a little differently. I'm going to eliminate x's here instead. And just again to show you that there's really no difference. So what I'm going to do is I'm going to take the top equation. I have negative 9x minus 6y plus 4z is equal to 8. And I want to take the bottom equation and multiply the bottom equation by positive 3. So if I do that, I will end up with 9x plus 18y minus 9z is equal to negative 18. And what I'm going to do with this is I'm going to add the two equations together to eliminate x's. If I do that, I'll end up with positive 12y minus 5z is equal to negative 10. All right, so what I'm going to do next is I'm going to take this the second and third equations, okay, and I'm going to again eliminate x's. So I'm going to write out the second equation, which is 3x plus 6y minus 3z is equal to negative 6. In the bottom equation, I'm going to multiply everything by negative 1, which is negative 3x plus 6y minus 2z is equal to negative 4. And I'm going to add everything together. I'll end up with 12y minus 5z is equal to negative 10. Let's look at this. We have two equations now, okay, where we only have x's and y's. I'm sorry, I just noticed that this should be a z here, not a y. I have two equations here with the same, I have two identical equations. What does this mean? Well, I can continue doing the problem, certainly. I can write 12y minus 5z is equal to negative 10. 12y minus 5z is equal to negative 10. I can certainly do that, okay? And, subtract everything from this, okay? And add, multiply the bottom equation by negative 1 and then add. I'll just end up with 0 equal to 0. What does this mean? If I end up with two equations that are identical to one another, well, the implication is we actually have infinite solutions. And the reason why we have infinite solutions is these are all actually, they're actually the same equations, okay? You know how when we had infinite solutions with linear equations, two linear equations, they're one on top of the other? Well, it's the same situation here, okay? Any value of x, y, and z that you plug in, okay, it doesn't matter, okay, what it is, it'll work for all three equations. So that's what it means for the system to have infinite number of solutions.